All right, guess what unit this is? Unit 10. How many units are there? 11. Almost done. It's been a long semester, right? But the end is near. Well, the good end is near. That sounded awfully apocalyptic, didn't it? All right, well, Unit 10, as we said in the introductory video, is about writing polynomials in factored form. Unit 9 was about trying to write them in standard form or simplified form, but we're going in reverse now. All right, so hopefully you have Unit 10 guided notes A in front of you, and we're going to go over that sheet right now. Okay, now let me cover this up. You should do those two warm-up problems first. Oh, don't look. Do those two warm-up problems first. In fact, stop the video and work those two warm-up problems real quick. All right, did you do it? All right, those are the answers to the two warm-up problems, okay? Now, again, you started off in factored form. That's factored form, and your answer was in standard form or simplified form. It's the same thing, okay? Now, GCF stands for, what we're going to be doing in this section, we're going to be doing this in reverse. GCF stands for greatest common factor, and it is the blank property in reverse. What property is it in reverse? Well, what did you just do up here? You distributed. GCF is the distributive property in reverse. Now, on Desmos, you're going to be using a function. If you don't know your times tables inside and out, you can use Desmos and a feature called GCD. That stands for greatest common divisor. They don't call it greatest common factor. They call it greatest common divisor on Desmos. But you're going to use that to help you along a little bit. And how we do it, we're going to identify the greatest common factor. And for exponents, you use the smallest one. I'll show you that in a minute. We're going to write the greatest common factor outside the parentheses, and we're going to use division to write what's left inside the parentheses. All right, let me make sure I've got Desmos on the computer here so I can get to it real quick when I share my screen. There it is. All right, so let's get everything ready to go. All right, now I realize that my handwriting is not real good when I tried to squeeze in really small spaces like that. So I'm going to do that. I'm going to write it really big. So that's the first example. Okay. What your answer is going to look like, you're going to have a greatest common factor on the outside, and you're going to figure out what's left on the inside. This is what your answer is going to look like. Now, what is the largest number that divides evenly into 18, 24, and 40? Now, I know that 2 goes into all 4 of those numbers. So does, well, I don't know if 3 does, but let's see. If you're not sure what's the largest number that divides into all 3, let me show you how you do that. All right, I'm going to show you how to do that real quick. Let's go to, all right. Let me show you how you do that. All right, the way you do that, come on, is you type in GCD, and then in parentheses, you're going to type the numbers you're trying to find the greatest common factor of, separated by a comma. So 18, comma, don't put negative numbers in here, just put the positive numbers. 18, 24, and 40. Oh, it's only 2. The biggest number that divides into all 3 numbers is only a 2. I thought it was going to be larger than that, but it isn't. All right. So we're going to write, we know that the greatest common factor, the largest number that divides into 18, 24, and 40 is 2. But let's look at the exponents. The exponents are 3, 2, and 1. The highest exponent is a 1. I mean, the lowest exponent is a 1. You have to use the smallest of the 3. So my greatest common factor is 2x. Okay? 2 is the largest number that divides into all 3. X to the 1. 1 is the smallest of the 3 exponents. Now you're going to write 2x on the outside. Now what goes on the inside? You are going to divide all three terms by the greatest common factor. So put a 2x underneath all three terms, and we're going to divide and see what's left. All right, what is 18 divided by 2? 18 divided by 2 is 9. What do you do with the exponents when you divide? 3 minus 1, I'm sorry, is 2. Plus 24 divided by 2 is 12. And on the exponents, 2 minus 1 is 1. You don't need to write the 1. Minus, finally, 40 divided by 2 is 20. And the exponent, 1 minus 1 is nothing. The x's are completely gone on that one. And this is factored form. You don't need to underline the greatest common factor. I just wrote a line there indicating that's where you put it. Now, how do you check your answer? Okay. 1, distribute. If you distribute, do you get the original problem back again? In other words, if you did that, would you get the original problem? You would. Also, do any of these terms have anything left in common? No, there's no number that divides into 9, 12, and 10. And there, if you look, there is the terms do not have an x in common anymore either. So there's nothing left in common. So that is the factored form. We took out the greatest common factor. That's called factored form. That's what that form is called. All right, let's do example 2. This is example 2. Now, once again, our answer is going to look like this. We're going to put our greatest common factor on the outside. We're going to distribute in reverse, and we're going to figure out what's left on the inside. The inside is going to look like this. You don't need to write the blanks, but I'm just showing you where I'm going to put things. This is what our answer is going to look like. It's going to be what it looked like before we distributed. Now, the greatest common factor, what is the largest number that divides into 25, 15, 25, and 45? The biggest number that divides into all three is 5. And again, you can use Desmos to figure that out. Now let's look at the x's and the y's separately. What is the smallest exponent on the x's? The smallest exponent on the x's is right there. It's x to the 1. What's the smallest exponent on the y's? You see a 3, a 2, and a 2. So the smallest exponent on the y's is a 2. So that's my greatest common factor. You're going to put that on the outside. Now, what's left on the inside, you're going to divide all three terms by the greatest common factor. So you're going to put 5xy squared under all three, and that's going to tell you what's left. All right, let's look at the first one. 15 divided by 5, what is that? That's 3. Now, on the exponents on the x's, 2 minus 1 is 1. You don't need to write the 1. And 3 minus 2 is also 1. You don't need to write the 1. Let's move to the middle. 25 divided by 5 is 5. Now, on the x's, 1 minus 1, those are gone. There are no x's left. The y's, those are also gone. So the only term here, the only thing you have on here is a 5. That's it. Now, right here, 45 divided by 5 is 9. On the x's, 4 minus 1 is 3. And 2 minus 2, that's a 2. 2 minus 2, those are gone. So here is the factored form. I took out the greatest common factor. And if you distribute, you'll get the original problem back again. You can check by distributing. All right, example 3. Let's look at example 3. By the way, these pens are really toxic. Okay, so I'm worried about feeling a little bit lightheaded here. The smell is terrible. All right, this is example 3. All right, what is the largest number that divides into 18, 27, and 9? The largest number that divides into all three is 9. What is the smallest exponent on the x's? 2, 1, none. So if the smallest exponent on the x's is none, you cannot put an x here if one of the terms doesn't have an x. You cannot take out an x. Now, another thing I want to point out, if the first term is negative, then you should put a negative over here on your GCF. Now, your GCF, now I'm going to emphasize, I can't emphasize enough, there is no x on your greatest common factor because one of the terms did not have an x. So if one of them doesn't have an x, do not put an x on your greatest common factor. So our example, our problem is going to look like this when we factored it. So let's put a blank here, a blank here, and a blank here. I'm not going to put the signs in here because something weird is going to happen with the signs. You got to be careful. Put a -9 out here. All right, let's write down. Let's divide all three of these by -9. All right. What is -18 divided by -9? That's a +2. Now, there is no x down here, so there's nothing to subtract on the exponent, so that stays x squared. What is -27 divided by -9? That is a +3, and that's a 1. There's no x down here to subtract, so that's going to remain x to the 1. What is 9 divided by -9? -1. Now, how do you check? If you distribute, do you get this problem back again? And you do. So this is factored form. All right, last example. This is a tough one. Now, again, 48, 64, and 72, those are big numbers, all right? Let's see, what is the GCF for 48, 64, and 72? I'm going to share my screen again. If you don't remember, I'll type that in for you. Let's see. Again, do you remember how to do it? I'm going to type GCD 48, 64. You don't need to put the negative here. Don't, in fact, don't. And 72. What is the greatest common factor? It's 8. 8. All right, so it's an 8. So I know that part of it. Just got to do the rest of it. All right, so we got the GCF is going to be 8. Now let's look at the A's. What's the smallest exponent on the A's? The smallest exponent on the A's is a 2. What's the smallest exponent on the B's? The smallest exponent on the B's is a 2. What's the smallest exponent on the C's? A 5, a 2, a none. So your GCF cannot have a C because one of your terms did not have a C. So don't put a C on that. All right, so I'm going to put 8a squared b squared on the outside. Now let's figure out what goes on the inside. I went ahead and wrote the signs because I'm not taking out a negative. All right, let's put 8a squared b squared underneath all three. And let's see what's left. 48 divided by 8 is 6. Subtract the exponent on the a's, they're gone. So there's no a's left on that term. 3 minus 2 is b to the 1. There are no c's down here to subtract from, so that'll be c to the 5th. All right, what is -64 divided by 8? That's -8. Subtract the exponents on the a's. 4 minus 2 is 2. Subtract the exponent on the b's. 2 minus 2 is none. The c squared is still there. Now 72 divided by 8, that's 9. 4 minus 2 on the a's, that's 2. 6 minus 2 on the b's, that's a b. 6 minus 2 is 4. So there's factored form right there. And again, you can check by distributing. And notice again, there is nothing in common with these three terms anymore. So that is factored form. All right, I hope you get an understanding of how to take out the greatest common factor. We are done with Guided Notes A.